Okay, in this first example of finding the area for regular polygons, we are given an equilateral triangle with the perimeter being 9 centimeter. Now recall the three formulas of the area of equilateral triangle, which is square root of 3 over 4 multiplied by the size raised to the second power. Formula for the area of a triangle, which is 1/2 times base times height, as you have been seeing. And this formula is applied to all the triangles. And lastly, we had a formula for the area of a regular polygons, which is 1/2 multiplied by the apothem and multiplied by the perimeter, which is period I wrote here. So remember that equilateral means all sides are equal. So this triangle has all sides equal. And we can find the value of the side by using the given perimeter and divide it by 3 because the triangle has 3 sides. So take the value of the perimeter divided by the number of sides. We are going to have the size equal 9 divided by 3 is going to be equal to 3 centimeters. So each side of this triangle is going to be 3 centimeters. So I'm drawing a picture. We have 3 here, 3 here, and 3 right here. Also recognize the fact that because this is an equilateral triangle, it is also equiangular. That means each angle has the same degree. So by the triangle angle sum theorem, we know that for any type of triangle, all 3 angles added together has to give you 180 degrees. So that's why this is 60, 60, and 60. Now, using the first formula, which is the formula for the area of an equilateral triangle, we know that the area of this equilateral triangle, or this regular 3-sided polygon, I should say, is going to be A equal to the square root of 3 over 4 multiplied by 3 square, because the side is 3 centimeter. And this is going to give us, let's see, 3 raised to the second is 9, so we get 9 times square root of 3 over 4 centimeters square. And if you want to crank out in decimal form, this is approximately equal to 3.9 centimeters square. So this is your answer using the first formula. Now using the second formula, which is the area for any type of triangle, we have 1/2 times the base times the height. Well, we know the base already, but we don't know the height. So let's find the height first. And we can find the height by cutting this triangle into 2 halves, with this dashed vertical line being perpendicular to the base. And from here, we can consider either this half or this half. So let's consider the right half. So on the right half, we have something like this. And this is the right triangle. We know this has going to be 3. This is going to be 60 degrees. Well, if this is 90, this is 60, then of course this has to be 30 degrees by the triangle angle sum theorem, because remember that all 3 angles have to add to 180 degrees. But if we cut this triangle in half, then that means this half has to be 30 degrees. So for this triangle, all 3 angles have to add to 180 degrees as well. So that's by one reason as to why this angle is 30 degrees. Another reason is because we are bisecting this angle. And of course, when you bisect something, you cut it into 2 equal halves. So this half is 30, which is this one, and this half is 30 as well. But I'm just gonna not put it in. But anyway, we have these 3 angles, and we have the side 3 right here. Now for the base here, it is 3 centimeter. But if we cut this base in half, this has to be 3 over 2. So this is the value of the base. Now take a look. We have 30, 60, and 90 degrees. So by the 30, 60, 90 triangle property, we know that opposite to 30 degrees is going to be the short leg. And this short leg is denoted by the letter X. But at the same time, this short leg has a value of 3 over 2. So we know X is equal to 3 over 2. Opposite to 60 degrees is the equation X times square root of 3. But we know X is 3 over 2. So really, this dashed line right here, this long leg, I should say, is 3 over 2 times square root of 3. But hey, that's the height of the triangle that we're trying to look for. So this is the height, and this right here is the base. So using the second formula, we are going to have capital A equal to 1/2 multiply the base, which is 3 centimeter, not this base, this one, because we're trying to find the area of this entire triangle. And we multiply by the height, but the height is here, as you probably have seen. So the height is 3/2 times square root of 3. So that's going to give us what? Well, let's see. 1 times 3 times 3. That's going to give us 9. Keep the square root of 3. And then 2 times 2, that's going to give us 4. So hey, we got 9 times square root of 3/4 centimeters square. And that is the same as what we did up here. So that's the second formula, or the second way of doing this. Now the third way is by using the formula for the area of the regular polygon, or any regular polygon, I should say. So we know the perimeter, which is 9 centimeters up here, but we don't know the apothem. Now to figure this out, what we want to do is that we want to put this triangle in a circle, and then we have to cut it out into like different pieces inside that circle or inside this triangle, and then we have to figure out the apothem. So I'm gonna draw a picture on this other paper. In order to come up with the apothem, we had to remember that the apothem, the apothem starts from the center, and it goes directly, it touches directly one of the sides of the triangle, and it touches, or it intersects perpendicularly. So there's going to be a right triangle there. I mean the right angle, not the right triangle there. And this little part here is called the apothem. Now to come up with the apothem, what we want to recognize is that we want to cut this triangle into pieces. So maybe I'm going to call this here. So we got this triangle, and then we got this triangle, and then we got this triangle. So you see, this right here is the apothem of this triangle. This is the apothem of this one, but we are just going to look at this one instead, because all three are the same. So we're just going to pick one, and we're just going to find the apothem right there. Looking at this bottom triangle here, we know that earlier we know that this angle is 60 degrees. So by bisecting this angle, we know this is going to be 30, and this is going to be 30. And the same thing can be said for this angle. 30, 30, 30, and 30. And of course, that's the right triangle right here. I mean, not the triangle, the right angle. Again, my bad. So how do we find this apothem? Well, looking at this bottom triangle, we can pick either its right half or its left half. I'm just going to pick the left half instead. So picking the left half in here, yeah, I'm just going to write underneath. Like that. Well, from this left half, this angle here is 30 degrees. This is 90. 30, 90, the leftover has to be 60 degrees, like that. By the 30, 60, 90 triangle property, opposite to 30 degrees is the short leg denoted by a variable. We call it x. Opposite to 60 degrees is the long leg denoted by x times square root of 3. And opposite to 90 degrees is the hypotenuse denoted by 2x. But we know that this right here, this long leg, is half of the base, which is half of 3. So we know this equation has to be set equal to 3/2. Well, solving for x by dividing both sides by square root of 3, we get x equal, well, if you rationalize the denominator here, let's see, you're going to have, well, first of all, you're going to have 3/2 times square root of 3. But by rationalizing the denominator, you know that we're going to have 3 times square root of 3 over 2 times 3. But this is going to give us 3 times square root of 3 over 6, which is square root of 3 over 2. And this is, and the x equal 3 times square root of 3 right here is going to be right here. And this is the apothem. Well, once we have the apothem, guess what? All we have to do is we just take the apothem and take the perimeter and plug it into this third area equation. So that means by the formula for the area of any regular polygon, we know the area of this equilateral triangle is going to be capital A equal to 1/2 multiplied by the apothem, which is square root of 3 over 2, and multiplied by the perimeter, which is 9. But hey, that's going to give us the same answer because 1 times square root of 3 times 9 is going to be 9 square root of 3. Denominators multiplied together is going to give us 4. So hey, 9 square root of 3 over 4 centimeters squared is our answer, which is the same as what we got using the first two equations.